At the edge of this forest, the trees do not end naturally. On one side, edible and useful species still rise in dense layers beneath an intact canopy. On the other, the same living system has been cut into open agricultural ground. The line between them looks like a border between wilderness and civilization, but the forest may be the cultivated landscape. I kept returning to an 1853 botanical survey by Alfred Russel Wallace. He recorded Amazonian palms not simply as species, but through their practical uses among indigenous communities. Other 19th century explorers also encountered forests unusually rich in edible, medicinal, and valuable plants. The accepted explanation is not mysterious. Indigenous societies managed many forests over long periods, but one detail refuses to disappear. Many of the trees remained. Those systems were disrupted by disease, settlement, colonial expansion, commercial agriculture, industrial forestry, and changes in land ownership. The knowledge that made their arrangement legible did not. Archaeological sites still contain high concentrations of domesticated and culturally important species. Herbaria still preserve specimens. Libraries still hold the surveys. Yet later generations learned to look at these landscapes and see untouched nature. So what vanished first? The forests that fed people, or our ability to recognize them? That problem does not end at the edge of the Amazon. It appears wherever a cultivated plant survives after the people who shaped it have disappeared from the explanation. In Africa, the investigation begins not with a forest, but with a few lines of type printed in South Carolina on April 26th. 1760. The advertisement announced the sale of enslaved people newly arrived aboard a ship from the Windward and Rice Coast. The original newspaper notice survives in a later photographic reproduction held by the Library of Congress. It is a small commercial document. There are no biographies, no agricultural descriptions, no account of what the people aboard knew before they were captured. But the words Rice Coast remain. The individuals were unnamed. The agricultural region was not. That distinction matters because the phrase was not decorative geography. It identified part of the West African coast associated in Atlantic commerce with rice-producing societies. Slave traders and colonial buyers recognized that regional identity well enough to print it in an advertisement. The document cannot establish that every person aboard was an experienced rice cultivator. It does not prove that this particular shipment was purchased exclusively for agricultural expertise. It does not tell us the motives of a specific buyer, but it does establish something narrower and more difficult to dismiss. Inside a system that reduced people to saleable inventory, African agricultural geography remained commercially legible. The region could be named because its production mattered. The people who had made that production possible were recorded as property. To understand what has been lost from that page, we have to move backward, before the ship, before the plantation, and before rice became associated in the Atlantic world with the fortunes of European landowners. The next piece of evidence is a seed. It is catalogued as CG14, International Rice Germplasm Collection Accession I.R.G. C96717. Its appearance is unremarkable. It does not resemble a monument. Nothing about an individual grain announces that it contains a separate history of domestication. But CG14 belongs to Oryza glaberrima, the cultivated African rice species. That botanical name separates two histories that are often collapsed into one. The rice most familiar across much of the modern world is Oryza sativa, the Asian cultivated species. African rice is not simply Asian rice planted in African soil. It is a distinct cultivated species descended from an African wild progenitor, Oryza barthi. African rice was domesticated independently in West Africa roughly 3,000 years ago. The exact geography remains under investigation. Genomic work has supported a leading model centered on the Niger River region and the inner Niger Delta, while other studies point toward a more complex history of domestication and diversification. The uncertainty is real. The independent African origin is not. This changes how the 1760 advertisement must be read. The phrase Rice Coast did not refer merely to a region where an imported crop happened to grow. It pointed toward societies connected to their own long history of rice cultivation, selection, processing, ecological adaptation, and landscape management. That history is preserved inside CG14. In 2014, researchers used the accession in a major African rice genome study. The sequence allowed comparisons among cultivated African rice, its wild relatives, and Asian rice. Within the chromosomes were signs of domestication and adaptation to African environments. The seed had become an archive. It did not preserve the name of the first cultivator who selected one plant over another. It could not identify the households that protected seed through drought, flood, migration, or political change. Genomics does not recover individual motives or reconstruct forgotten conversations, but it can reveal biological relationships that written records never described. The African domestication of rice had survived even where authorship had not, and CG14 did not remain only an object of historical study. It became one of the African parental lines used in the development of new rice for Africa, or Nereka, breeding lines that combined characteristics of African and Asian rice. A domestication process begun thousands of years earlier entered modern crop science through a preserved accession. What looked like an old seed was still participating in the future of agriculture. Rice, however, could still be treated as an exceptional case. To test whether it belongs to a larger pattern, the investigation has to leave the river systems of West Africa and examine materials that appear even less informative than a seed. Fragments of pottery from northern Mali contain impressions of pearl millet. Some traces are chaff, others preserve the form of spikelets, or grains that came into contact with clay during pottery production. The plants themselves have largely disappeared. Their shapes remain embedded in ceramic fabric. Across material dating to the 3rd millennium BCE, archaeologists have identified a transition from wild toward domesticated pearl millet. In the Tilemsi Valley, clearly domesticated forms appear by approximately 2500 BCE. The date is approximate. The physical change is visible. Domestication alters plants. Human selection can favor larger grains, reduced natural seed dispersal, more predictable growth, and characteristics useful in harvesting or processing. These changes accumulate over generations. In northern Mali, part of that process became trapped in pottery. No written account was required. The clay preserved the work. Pearl millet later moved far beyond its western Sahelian domestication region. Archaeological and genetic evidence traces its expansion eastward across Africa and eventually into South Asia during prehistory. The exact routes and chronology continue to be refined, but the broader movement is clear. An African domesticate became the part of food systems thousands of miles from its origin. Its journey is rarely presented with the same familiarity as the westward movement of wheat or the post-1500 spread of maize and potatoes, but its material biography is no less global. Farther east, evidence from Sudan reveals another domestication history. Sorghum remains and plant impressions preserved in archaeological contexts include domesticated forms dating to the 4th and 3rd millennia BCE. Some survive inside pottery. Others appear as charred botanical material. Again, the archive is physical before it is written. The shape of a grain, the structure of chaff, and the microscopic remains of processing can record the development of agriculture, where no royal inscription or administrative tablet survives. The pattern is beginning to expand. West African rice was independently domesticated. Pearl millet was domesticated in the western Sahel and carried far beyond it. Sorghum developed through another African agricultural history farther east. West Africa also became a major center of yam domestication. Genomic research on white Guinea yam supports its origin through domestication from West Africa African wild populations. Other crops complicate the picture further: fonio, cowpea, finger millet, teff, indigenous vegetables, fruits, and locally adapted plant varieties whose significance often remains regional rather than globally branded. This was never one African agricultural revolution. The continent contains deserts, highlands, tropical forests, savannas, wetlands, river deltas, and Mediterranean environments. Different societies cultivated different species under different ecological pressures. The evidence does not support replacing one simplified origin story with another. Agriculture did not emerge in one place and then radiate outward to passive recipients. Current research recognizes multiple independent centers and extended regions of domestication: Southwest Asia, East Asia, New Guinea, Mesoamerica, the Andes, several parts of Africa, and other regions. Africa did not invent all agriculture. It did not produce every crop that feeds the world, but it was one of the places where human communities independently transformed wild plants into cultivated species. That should make Africa central to any global history of food. Yet, in popular narratives, it often appears later, as a continent receiving crops, supplying labor, producing commodities, or suffering shortages. The sequence has been reversed. To understand how that reversal became plausible, it helps to examine another surviving object: a world map. Gerardus Mercator developed his famous projection in the 16th century for navigation. Its crucial advantage was technical. A course following a constant compass bearing could be represented as a straight line. The projection preserves local angles. It does not preserve area. As a result, land masses at high latitudes appear greatly enlarged in relation to those closer to the equator. Greenland becomes visually comparable to Africa, even though Africa is vastly larger. Northern Europe and Northern Asia expand. Equatorial regions contract. There is no evidence that Mercator designed the projection as an anti-African political instrument. The distortion follows from its mathematical purpose, but a map created for navigation later became common in classrooms, atlases, publishing, and public display. A technically valid tool began performing a task for which it was poorly suited. The consequence was not that Africa disappeared. It was that generations learned to underestimate its scale while looking directly at it. The map offers a useful analogy for the history of African agriculture. The problem was not always the destruction of evidence. It was the repeated use of interpretive systems that made existing evidence appear smaller. In the biological record, African rice remained distinct. In pottery, pearl millet and sorghum remained visible. In fields, farmers continued planting indigenous crops, but conventional histories often organized the past around the Fertile Crescent, Mediterranean antiquity, European expansion, and the post-1500 exchange of plants across the Atlantic. Within that frame, Africa appeared primarily as a destination or a source of labor, not as a region of independent agricultural invention. The title, "The Continent That Fed the World," therefore has to be tested carefully. No single continent fed the world. Modern global diets depend on plants with many origins: wheat and barley from Southwest Asia, Asian rice from East and South Asia, maize from Mesoamerica, potatoes from the Andes, cassava from South America, and numerous other species. Africa's agricultural history does not need exaggeration to become significant. The physical evidence already shows that African crops entered food systems beyond the continent, and that African farmers developed species adapted to heat, drought, variable rainfall, difficult soils, and other conditions that now matter increasingly to global agriculture. The evidence has established the innovation. The larger question is how that history became less familiar than the evidence warrants. The 1760 advertisement provides one part of the answer. It belongs to an archive constructed by the Atlantic slave economy. Plantation and commercial records were designed to track ships, prices, owners, insurance, acreage, exports, purchases, and categories of labor. They were not designed to preserve the intellectual biographies of enslaved cultivators. This created a structural imbalance. The plantation owner appeared by name. The merchant appeared by name. The ship appeared by name. The value of the cargo was calculated. The people whose knowledge made production possible were often grouped by age, sex, physical condition, place of embarkation, or commercial region. Their agricultural experience could be economically useful without becoming historically credited. In parts of the American South, enslaved Africans arrived from societies with established knowledge of rice cultivation and processing. The Library of Congress and a substantial body of historical scholarship recognize that African experience contributed indispensable skills to rice and indigo production. The evidence appears across several forms. There are records linking captives to rice-growing regions of West Africa. There are similarities in processing methods. There are mortars and pestles. There are winnowing techniques. There are coiled baskets associated with rice cleaning. There is linguistic evidence. There are provision grounds and cultivation practices maintained within enslaved communities. There is the survival of African rice in the Atlantic world, and there are the engineered plantation landscapes themselves, dikes, canals, embankments, floodgates, and tidal fields built through intensive labor and environmental knowledge. But the exact history of technological transfer remains debated. Not every feature of Carolina or Georgia rice cultivation can be assigned exclusively to one source. Historians disagree about the relative contributions of West African practices, European precedents, indigenous American knowledge, and techniques developed under plantation conditions. That uncertainty does not erase the broader evidence of African expertise. It prevents a different mistake, turning enslaved Africans into a single undifferentiated group, credited with every development. The historical record supports a more precise conclusion. People taken from African rice-growing regions carried relevant knowledge into Atlantic plantation societies. Plantation systems exploited that knowledge. The archives rarely preserved its authorship with the same care used to preserve ownership. A rice fanner basket in the Smithsonian's National Museum of African American History and Culture makes this imbalance visible. It is an agricultural tool associated with rice processing in South Carolina. Its materials and construction belong to a world of skilled handwork. It represents a stage of production often overshadowed by images of plantations, export warehouses, and wealthy houses. Rice did not become a valuable commodity simply because land was available. It required seed selection, planting, water control, harvesting, threshing, pounding, winnowing, storage, and repeated judgments about weather, soil, and timing. The basket brings one part of that chain back into view. It also changes the meaning of the word labor. Plantation records often treated labor as an amount, a number of workers, a number of days, a cost of production. The basket reveals labor as knowledge enacted through the body. That knowledge could be transferred without being acknowledged. It could survive as practice while disappearing as authorship. The same separation can be seen in the advertisement. Rice Coast recognized an agricultural region. The individuals from that region remained unnamed. The archive did not fail to record everything. It recorded what the commercial system considered important. After emancipation, that imbalance did not simply disappear. European colonial administrations expanded agricultural departments, experimental stations, irrigation schemes, export programs, surveys, and systems of crop classification across much of Africa. These institutions produced enormous quantities of documentation, but they did not value every form of cultivation equally. Crops linked to metropolitan industries, state revenue, or export markets often attracted concentrated attention. Cotton, cocoa, coffee, palm products, timber, and other commercial commodities received infrastructure, research, transport, inspection, and administrative support. Local food cultivation was frequently classified as subsistence agriculture. The term appeared descriptive. It carried consequences. A system labeled subsistence could be treated as static, technologically limited, and economically secondary. That classification obscured seed selection, local trade, experimentation, ecological knowledge, risk management, food processing, and the work of women who often maintained crops and varieties beyond the priorities of colonial institutions. The crops did not have to be prohibited to become marginal. They only had to remain outside the systems that generated scientific prestige, investment, statistics, and markets. The plantation archive and the colonial survey were not identical, but both separated what was being measured from forms of knowledge their categories were not designed to recognize. One enlarged ownership and production. The other enlarged export value and administrative control. In both cases, agricultural expertise could remain materially present while becoming institutionally smaller. This is where the word erased becomes both useful and dangerous. There was no single institution carrying out one coordinated removal of African agriculture from history. The evidence supports accumulation rather than conspiracy. Slavery separated knowledge from named practitioners. Colonial administration separated export agriculture from supposedly backward subsistence. Commodity markets rewarded some crops and neglected others. Academic traditions concentrated excavation and historical attention unevenly. Modern agricultural science directed resources toward a limited number of internationally important species. Popular histories simplified multiple domestication centers into a few familiar narratives. Maps, atlases, museums, textbooks, and public displays repeated those narratives until they began to feel natural. Each process had its own purpose. Together, they changed what appeared historically important. Crop substitution added another layer. Maize, cassava, peanuts, Asian rice, wheat, and other introduced plants expanded across African regions after entering through trade and post-1500 exchange networks. Their adoption cannot be reduced to colonial imposition. African farmers were active decision-makers. They tested new plants, selected varieties, rejected unsuitable crops, combined species, and adapted introduced foods to local environments and cuisines. Some incoming crops offered advantages in yield, storage, processing, labor demands, ecological tolerance, or market access. Government policy and coercion also mattered. So did trade, population change, land pressure, and shifting diets. As maize and cassava expanded, some indigenous crops contracted geographically or became associated with hardship, remoteness, or poverty. Asian rice spread widely without completely eliminating African rice. White Guinea yam remained important even as introduced crops competed with it. The historical change was not a clean replacement. It was an uneven reordering of attention, land, labor, markets, and prestige. By the 20th century, this reordering had become embedded in agricultural research. International and national programs concentrated heavily on a relatively small group of major crops. Species cultivated mainly for smaller markets or within particular regions often received less investment in formal breeding, processing technology, extension services, storage, commercial seed systems, and marketing. This is why modern institutions began using terms such as orphan, neglected, underutilized, or lost crops. The words can be misleading. Many of these plants were never lost to the farmers who continued cultivating them. They were lost to systems of institutional attention. The National Academy's Lost Crops of Africa project examined African rice, finger millet, fonio, pearl millet, sorghum, indigenous vegetables, fruits, and other food plants. Its concern was not that these species had vanished, but that scientists, policymakers, and development institutions had repeatedly overlooked their potential. The modern report becomes another piece of evidence. A scientific institution was acknowledging that crops long maintained in African fields had remained underdeveloped within formal research systems. The plants were present. Recognition was missing. This is the same reversal found at the forest edge. A managed landscape can be mistaken for untouched nature when the system that explains it disappears. A cultivated crop can be treated as minor when the institutions that assign importance were built around other commodities. A body of expertise can be recorded as labor when the archive was created to document ownership and profit. The physical evidence survived better than the categories used to interpret it. That survival is now producing unexpected returns. African rice contains traits associated with adaptation to difficult African environments. Sorghum and pearl millet have long histories in regions marked by heat and irregular rainfall. Fonio, cowpea, yam, teff, and related wild populations contain biological diversity relevant to drought, poor soils, disease, and changing climate conditions. Their value did not suddenly appear when modern laboratories noticed it. The value was already present in plants selected and maintained over generations. Modern genetics can identify some of that inheritance. Germplasm banks can preserve it. Breeders can recombine it. But scientific recovery creates another historical question. When a trait from an African crop becomes useful to global agriculture, whose history travels with it? CG 14 offers a partial answer. The accession number preserves institutional identity. The genome preserves biological ancestry. The breeding record preserves its role in modern research. But the earliest cultivators remain unknown. The seed carries the outcome of their decisions without their names. Across the Atlantic, another form of survival appears in rice maintained by maroon communities in Suriname and French Guiana. These communities were formed by people who escaped slavery and established independent settlements under difficult conditions. Rice varieties preserved within them have become subjects of genomic research investigating relationships among African and Asian rice histories. The evidence does not provide a simple route map for every grain. It does something more careful. It shows that plant history can survive through descendant communities, even when formal colonial archives are incomplete. A seed may cross an ocean under circumstances that were never fully recorded. It may continue to be planted after the institution that transported it has disappeared. Its descendants can preserve relationships that no surviving shipping ledger explains. This is why the investigation cannot remain inside one archive. Archaeology holds grains and impressions. Herbaria hold classified specimens. Germplasm collections hold living accessions. Genomes hold patterns of descent. Plantation records hold prices, acreage, exports, and categories of labor. Museums hold baskets, tools, and processing objects. Colonial reports hold institutional priorities. Descendant communities hold practices and varieties that outlived the systems attempting to control them. No single collection contains the complete history. The pattern becomes visible only when the evidence is reunited, and once it is reunited, the idea of disappearance becomes more precise. African agriculture was not erased because every trace was destroyed. It became difficult to see because the traces were separated. The seed was placed in botany. The grain impression was placed in archaeology. The enslaved cultivator was placed in labor history. The plantation was placed in economic history. The basket was placed in material culture. The colonial crop program was placed in administrative history. The modern accession was placed in genetics. Each discipline preserved part of the story. Public memory rarely assembled the whole. The Mercator map now becomes useful again, not as proof of intention, but as an example of how distortion can persist without a secret designer. A projection built for navigation can enlarge some regions and reduce others when used as a general picture of the world. An archive built for commerce can enlarge owners exports, and property while reducing the knowledge of enslaved people. An agricultural bureaucracy built around revenue can enlarge export crops while reducing locally managed food systems. A research economy built around international markets can enlarge a few major species while reducing crops maintained by smaller communities. None of these systems has to remove Africa completely. Each only has to make other histories easier to see. That is the defensible meaning of the title. They were not one hidden organization. At different moments, they were slave traders who recorded people as inventory, plantation archives organized around property, colonial agricultural departments that privileged commercial crops, publishers and educators who repeated simplified histories, research institutions that concentrated resources, and commodity markets that rewarded some plants more than others. Their actions were not identical, their effects accumulated. The result was a history in which Africa appeared to supply bodies, land, and raw materials more readily than invention. But the evidence refuses that arrangement. Oryza glaberrima is a cultivated species with an independent domestication history. CG14 carries that history in its genome. Pearl millet preserves domestication in Malian pottery. Sorghum remains record agricultural transformation in Sudan. Yam genomes point back to West African wild populations. Rice processing tools preserve skilled practice in the Atlantic world. Plantation landscapes reveal the scale of engineered labor. Maroon rice preserves plant relationships beyond the reach of complete colonial documentation. Modern reports acknowledge that crops called lost were still being grown. None of this proves that Africa alone fed the world. It proves something more historically important. The world's food systems emerged from multiple centers of human experimentation, and Africa was one of them. Its contribution was not absent from the record. It was distributed across records that were rarely read together. There are still limits. The precise geography of African rice domestication remains debated. The routes by which particular crops moved across Africa, Asia, and the Atlantic continue to be refined. The arrival of African rice in specific early American contexts is not equally established in every case. The technological origins of individual plantation features cannot always be assigned to a single tradition. The identities and biographies of most enslaved cultivators remain unrecoverable, and the degree to which present underinvestment results from colonial legacies, later economic decisions, agronomic constraints, or market preferences varies by crop and region. These uncertainties do not weaken the central conclusion. They define its boundaries. The evidence supports historical minimization, not a universal conspiracy. It supports continuity, not total disappearance. It supports African innovation without claiming African exclusivity. And it shows why the surviving objects matter. Return to the advertisement from April 1760. The words Rice Coast now carry more than a location. Behind them stands an independently domesticated rice species. There are river landscapes, generations of seed selection, processing techniques, local ecologies, and agricultural societies that existed before the Atlantic plantation economy. The advertisement recognized enough of that geography to make it commercially useful. Then it stripped away nearly everything else. The people became anonymous. The region became a selling point. Now return to CG14. The accession is also anonymous, but in a different way. It preserves no written author. It records no single inventor. Its genome is the accumulated result of decisions made across generations. One document preserves commerce without biography. One seed preserves domestication without a written archive. Together, they reveal what historical erasure actually looked like. It was not the disappearance of every crop, every tool, or every trace. It was the separation of knowledge from the people who produced it, labor from authorship, plants from their places of origin, and evidence from the larger history it could explain. The continent was never absent. We had learned to read the record without recognizing it.